Welcome to section 4.1, integer exponents. Okay, so first off, more than likely you have seen the rules of exponents coming into this course, but if you haven't, this is a great time to see it, and if you need any extra help with the rules of exponents, once again, please come by my office hours. So first off, I'm just going to give you all the rules of exponents, as I'm assuming you have seen some of them by now. So the first rule of exponent, the main one, is we have a to the first power is going to equal itself. A. Pretty simple. Next one, we have a to the 0 power. Anything to the 0 power is going to be 1. Now this is a little odd, and if you want to know why, please come by an office hour and I'll show you a neat way on how we know that. Next we have a little more interesting. If we have a base a to the m power, some random power, times a to the nth power, what we'll do is we'll keep the base and then we're going to add up the exponents. Okay, so we keep the base. This only works if the base is the same number. And then we add the exponents together. All right, what is one of the next rule? So the next rule we have is if we have a to the m power divided by a to the n, so a little different. If there's a division, instead of adding the exponents, we're going to subtract them. Now this one, the main thing you need to remember is it's always going to be the top one minus the bottom exponent. All right, what's another rule that we have? Well, another rule we have is the power rule. A to the m to the nth power. Now this one, what we'll do is we'll take a, m, and then we multiply that other exponent to it. So we have the parentheses, that should end up being multiplication. All right, a few more to go. So one of the next ones we have is if we have a and b to the nth power, so notice we bring in a new base, b, what we'll go ahead and do is we can distribute this if, now really be careful here, this is where a lot of students get messed up. If there's multiplication going on with the a and the b, we could distribute the m, so it'll be a to the m times b to the n. This does not work if we have a plus b to the m power. Does not work. Big no, sad face if you do that on an exam, okay? Does not work if you have addition or subtraction. Only works if you have multiplication, all right? So please make sure to check that on your exams or just in your homework and everything else. All right, so what is one of the next rules that we have? Well, we have another sort of form of the distribution. So instead of multiplication, we have the other one, which is division. So same thing happens, you can distribute it in, so we have a to the m over b to the m as well. And lastly, we have one other rule, which is what I like to call fish out of water. If you have a to a negative exponent, we cannot have negative exponents when we're working with polynomials or integers. Polynomials. So because we can't have a negative exponent, what we're going to do, I like to think of a fish out of water. If you have taken a fish out of the water, it should be in a negative mood, right? How do you make a fish happy? Well, you should put it back under the water, right? So go ahead, put it under the water. Think of this as your water line. It's a fraction line. We have a to the positive n power because your fish is now happy. Okay? That was something that a friend said to me once when we were both in math class, and I just thought it was a cute example. But the reciprocal rule. It's a good thing if you need to get rid of a negative exponent. One thing to note, the only time you're allowed to have a negative exponent in a math problem is with scientific notation. Sinota, the only time you can have a negative exponent. Other than that, you should always change your negative exponents to positive exponents. And how do you do that? You'll use the lovely fish out of water rule. All right, so let's go ahead and take a look at using these. Simplify the following. Okay, let's see, what do we have here? Well, we have two numbers, 8 to the 5th power and 8 to the negative 3rd power, and what are they doing? They are being multiplied. Okay, so one thing we need to note, none of these rules of exponents deal with addition in the beginning. So if you notice that all of these ones here on the side, do any of them have addition or subtraction going on? The answer is no, so note, these are only working with multiplication or division. So since we have multiplication going on, I know I can use rules of exponents. So I'll keep the base, which is 8, and I'll add the exponents, 5 plus negative 3. So 5 plus negative 3 is going to be 8 to the 2nd power. Now, some students say, well, you could technically write that out. So, it would be considered more simple if you wrote 64, because 8 to the second power is 64. If it's anything to the third power or higher, I usually don't require you to write it out. Okay? So safest, if you have anything to the second power, you should go ahead and continue to the actual squared version. Let's take a look at the next one. Ooh, these are all multiplications going on. See, that's all just multiplication. So let's write this all out so we can see the multiplication actually going on. Be less confusing. All right, well, we have a bunch of similar bases here. We have x and an x, then we have y and a y. And we can even be sneaky and say, you know what, that 25 is 5 to the second power. So we have 5 times x times y squared times 5 to the second power times x squared times y. So I'm going to go ahead and regroup these. It's all multiplication, so it doesn't matter how I group it. I'll go ahead and group the 5's together, the y's together, and the x's together. And then we can see how we can use the rules of exponents. So 5 times 5 squared times x squared times y squared times y. Now, using the rules of exponents, we'll keep the base. So keeping the base for 5, adding the exponents 1 and 2, that'll be 5 to the third power. Times, well, keeping the base for the x's, adding the exponents, that's 1 plus 2, that'll be x to the third power. Now you need to remember, if we ever have a variable by itself, it is technically to the first power, so keep that in mind. And lastly, we have x, we'll keep the base of y, that should have been y, and we'll add the exponents, so that's 2 plus that invisible 1, and once again to the third power. So we have 5 to the third power, x to the third power, and y to the third power. And we are done. Alright, let's take a look at the last one for this example. I'm going to rewrite it on the side here, so 5x to the 0 power, 2xy to the second power. Ooh, very sneaky. Look at this. We have something raised to the 0 power. Well, anything raised to the 0 power is supposed to be 1 by my rules. So that's just going to go ahead and equal 1. So you just have 1 times 2xy to the second power. Well, I could just rewrite that without that 1. Now what do we do? Now we have something that looks an awful lot like this rule right here. Because we have the multiplication going on the inside, we can go ahead and distribute that 2 to each of the terms. So the x, the y, and the 2 each get the 2. So we get 2 squared times x squared times y squared. Once again, we can only distribute that exponent when what? We have the multiplication or division. Alright, we can simplify that. 2 squared is 4, I know that. X squared, y squared. And we're done. Now let's take a look at example 2. Do as indicated. Oh, wow, this one's weird. You might be tempted to try using rules of exponents, but take a closer look. We have addition going on. Remember, exponents don't work with addition, so all we can do is simplify the numbers by themselves. We can't combine them. 1 to the 0 power, well, anything to the 0 power should be 1. Well, that didn't change much. Plus, and then we have negative 1 squared. That is negative 1 times negative 1, which is positive 1. So we'll go ahead and write 1 down again. And then we have 1 to the 5th power. Well, 1 to the 5th power is equal to 1 times 1 times 1 times 1 times 1, which is just 1. Interesting. And lastly, we have 1 to the negative 1 power. Well, 1 to the negative 1 power, that's the reciprocal rule, right? So to make it positive, we'll put it over 1 and 1 to the first power. But 1 to the first power is just 1. So we have 1 over 1, which is also equal to 1. Okay, all of these just simplified to being 1. How interesting is that? And now, since there are no more exponents, we can actually add them up. So we have 1 plus 1 plus 1 plus 1, which is 4. Well, that was kind of a mind-boggling problem. Okay, let's take a look at B. What do we have here? Ooh, I see those negative exponents. And as usual, we can't have negative exponents. So what do? Well, we'll do fish out of water. So we'll take the reciprocal. That's going to be 1 over 3 to the positive 1. plus 1 over 2 to the positive 1. So now we just have these two fractions that we have to add. How do we add fractions? We need a common denominator. Let's go ahead with 6. So that means I need to multiply the 3 by a 2 and a 2. And I need to multiply the 2 by 3 to get them both to have a denominator of 6. Let's check. 3 times 2 is 6, yep. 2 times 3 is 6, yep. So then on the top we just have 2 and then 3. And we're left with 5 over 6. Now let's take a look at the next ones. Oh, these are way more complicated, but have no fear. So the first thing I do whenever I see something that's massive like this, I like to look inside the parentheses and see if I can simplify anything first. Let me write this out so it's a little less teensy-weensy. And when I do that, it helps my brain sometimes to see things a little clearer. And I notice we have a lot of like term bases here. We have x to the 4th and x to the negative 6. And then we have y to the 6th and y to the 7th. And we also have the 3 and the 15. I can simplify those. So let's go ahead and simplify the 3 and the 15. Simplifying that out, we'll get 1 and 5 left over. So it's going to be 1 over 5 times, and we have x to the 4th times x to the negative 6. So let's go ahead and use the subtraction rule. So that'll be x to the 4 minus negative 6 times, and then we'll go ahead and do these guys. So that'll be y to the 6 minus 7. All to the negative 3rd power still. Alright, so then we have, well, these technically, you can still put these over 1 if you would like to. We have 1 to the 5th power times. So that becomes an addition there. So that's going to be x to the 4 plus 6 is 10. Times y to the 6 minus 7, that's going to be negative 1. And that is still to the negative 3rd power. Alright, and then we have, multiplying all of these together, we get x to the 10th, y to the negative 1 over 5. All to the negative 3rd power. Okay, last thing to do, we can go ahead and distribute in that negative 3 to all of them. And we get x to the, well, 10 times the negative 3. We have to be careful here because they all have extra exponents. That's going to be negative 3, y to the negative 1 to the negative 3, all over 5 to the negative 3. We're really running out of room here. Let's see. If we're moving to the side, we'll go ahead and use the side arrow to indicate moving to the side. So that'll be x to the negative 30, y to the 3rd power over 5 to the negative 3. Okay, so I'm going to go ahead and get rid of those negatives. How do I get rid of those negatives? Remember, to get rid of the negatives, we'll always just take the reciprocals. So that means we'll move them from the top to the bottom. So that'll be 5 to the 3rd power, now positive, x to the 30 power, now negative, or sorry, now positive again, and y to the 3rd, and we're done. Alright, let me go ahead and box off my work. Let's take a look at the next problem. This one looks a little less terrible. Let's take a look at the inside of the parentheses. Do we have any bases that are the same in there? No, not for that one. And then the other parenthesis, once again, nothing on the inside of the parentheses is the same. So I can't simplify like I did with the other problem. So this means what I'm going to have to do is I'm just going to distribute those exponents into the problem. Now, there's a different way to deal with this. If you see this problem before, we had that negative 3. So there were two options. We could totally just distribute it, or we could have taken the reciprocal and then distributed it. So I'm going to take a different path this time. First, I'm going to take the reciprocal of that negative 2 to get rid of that negative. And while I'm at it, I'm going to go ahead and distribute that 3 to all of the terms. So I have 2 to the 3rd power times x to the 3rd power all over y squared to the 3rd power times, and we take the reciprocal, so we get rid of that negative 2. We'll have y over negative 5x to the negative 2 to the 2nd power. So notice, everything on the inside, the signs and everything stay the same. All we do is we flip it, and our number now becomes a positive instead of being a negative. Okay, so we have 2 to the 3rd power, which is 8, times, and power rule. So we have 3 times 3 That'll be x to the 9th power all over. Y to the, well, 2 times 3 is going to be 6, y to the 6. Times, and let's go ahead and distribute that 2 in to all of the items. We get y squared all over. And we have the negative 5 squared, so that'll be 25, x to the negative 4. All right, ooh, the end is near, I can see it. Can we do anything else? Well, we have some of the same bases. We have an x and a y and a y. So let's go ahead and combine those terms. So we have 8, 25, x to the 9 minus negative 4 times y to the 2nd minus 6. Ooh, really running out of room here. Alright, so simplifying that out, I'm going to go ahead and continue my work here. Not the best example of showing neat work, but if you use your arrows, it definitely helps people follow. And then we have 8x to the, well, 9 plus 4, so that's going to be 13. Y to the 2 minus 6 is going to be negative 4, all over 25. Now, are we done? Nope, so close. We still have that negative 4. So to get rid of that negative 4, we'll go ahead and we have 8x to the 13th all over 25, y to the positive 4th power. And can we simplify anything else? Well, none of the bases are the same. We have an x, an 8, which is technically 2 to the 3rd power, and 25, which is 5 to the 2nd power, and y. So all of these are different bases, which means we're done. We can no longer simplify. And that's it. Alright, if you have any questions about this section, once again, please come by my office hour or send me an email.